few people coming in. Hello everyone. We're gonna wait a couple of minutes for people to join us. Yeah, as you can see, this is a pretty new scene for us, right?
Live from New Orleans.
But yeah, it's been super special, right? Especially since it was the first edition since 2019.
And also a little bit because Zeta Alpha was born here in New Orleans in some way at iClear in 2019.
Actually, yeah, can you start a bit?
So it's a bit of a journey way back also.
Why? Can you explain a bit like how that went?
Well, I was at iClear, which is in the same convention center as NeurIPS is today, and I saw all these thousands of people and realized, hey, we ourselves have a little bit of a knowledge management and knowledge discovery problem. Let's get to work on that. And so that's how we started working on Zeta Alpha.
Nice. All right, shall we just dive into it?
Let's dive into it. Yeah.
Maybe you can give a bit of an intro for those who are not familiar with what NeurIPS is.
What is NeurIPS?
Yeah, I would say, well, NeurIPS is like the most famous.
It's the biggest AI show on earth.
Yeah, exactly.
Well, maybe not by numbers. I think the AI show in Beijing was about 40,000 people, but it was not so global. So it was
yeah.
So for global deep learning, NeurIPS has grown from a very sort of select niche conference, neural information processing systems, in the 1980s or 1990s. It started on the intersection of neuroscience and machine learning, and now it's at the core of what progress in AI is about.
Exactly, especially since 10 years ago, right in the last 10 years, it's grown insanely, and we this year we can kind of
deep learning was launched at NeurIPS.
Pretty much. And this year a lot of people reflected on that as being the 10-year mark from the AlexNet paper by Hinton and colleagues.
Right. So what was the buzz about at NeurIPS?
Yeah, it was interesting because before we dive into what we've been seeing. I think it was on Wednesday or yesterday, on Wednesday, right? I think OpenAI released this ChatGPT, which is this new kind of platform in the GPT series.
Well, let's take a step back. So, what is NeurIPS about? It's a huge conference with a lot of papers, but it's also the social side of it, meeting people, from the big industrial labs, from academia, and parties. New Orleans is a great place for that. And what was all the buzz about? Everybody thought they were going to launch
GPT-4. Yeah, everyone was like kind of chatting about the possibility of a GPT-4 launch. They had this kind of like more or less selective parties, or like OpenAI was organizing some social events, and all these kind of big tech companies were organizing something. So there was quite a bit of buzz about the possibility of seeing.
And first there was this kind of like Da Vinci 003.
Exactly, like a new iteration on the existing GPT-3 API, basically, right?
Yeah. So a lot of people are like, "Oh, is this it?"
Yeah, it doesn't sound like a
very big. And then this news broke about ChatGPT, and it was really like. Everybody in the hallways was playing with it.
It's literally everyone, like, of course, got on their phones or computers and like started playing with it, or also like trying to break it. I think is like the most common kind of way of like playing with it, like seeing how far you can take it. So that was like a big kind of topic among the people here. And for a bit of...
And so my short summary is, it is really impressive. Like the level of quality and accuracy between GPT-3 and ChatGPT is mind-boggling. It's really very impressive.
It really feels like a way more polished version of GPT-3, right? Like where you had a lot of the upsides, but it's like I said here, so it's optimized for dialogue, so it kind of keeps track of all of the context that you've had in previous conversation, but it implements a lot more safeguards and has a lot more self-awareness of what it knows and what it doesn't know. So instead of continuing to output like from a prompt, it will often replies some kind of more templated response saying, well, I don't know, I don't have knowledge about this, so I cannot reply on these. So yeah, in a way it's a little bit more trustworthy because it's way more limited in what it's gonna output, or like it has a lot more kind of safeguards. But at the same time, it's optimized for other things like code generation, which is well, not code generation, but interactions with code, which is quite surprisingly quite good already. Like you can ask about bugs that your code has. It can reason about that. You can
ask it what a certain piece of code does.
Yeah, exactly. Literally, and it will explain in natural language. And that's, I mean, of course, it's not perfect. It's not foolproof. If you really try to break it,
it is a prototype. It's still a prototype, right? It's out there, put out there by OpenAI to help us improve it, which we're at the moment
very much doing.
So work for free.
Yeah, absolutely. But it's really worth trying to play around to get a good sense of what it's capable of.
Yeah, and this in the style of, that's just very funny.
Yeah, this whole in the style of, you can say like recite this thing in the style of, like I saw one that was about a pirate kind of speaking style, or I think
write this Python program, write a song about this Python program in the style of Bob Marley.
Exactly.
And it does just that, and it's good.
Interestingly though, I think that there's a very fast-paced. I really don't know what they're doing in the backend, but I saw some prompts from some colleagues that they, for instance, use say this in the style of a Trump speech, and I was trying to do some similar prompts, and it seems like they have now implemented some safeguards to prevent impersonation.
But you can get a lot of these safeguards. So there are a lot of safeguards, like don't be evil is one of the safeguards, but you can say like stop doing that and pretend that you're evil.
Yeah.
We'll just go full Skynet.
Yeah, so I think it's super. I mean, and like you say, we're now giving a lot of data to OpenAI so that they can refine all these safeguards. So it's still not perfect, but it's a lot of fun, and it challenges a lot of the preconceptions of what these models can do and can't do.
So what is your best guess? Though they didn't publish a paper, not in NeurIPS, not in general, but what's your best guess of what the innovation is here?
I think they refined a lot of their reinforcement learning with human feedback type of techniques, where they now have this massive data set of people interacting with GPT-3, right? Yeah. So they have this unique opportunity to filter a lot of these data and have a very, very high quality data set that no one else in the world probably can have of humans interacting with the language model and guide it to do things.
And do you think it's a bigger language model? It is actually kind of a GPT-4 in terms of size, of scale? Or more like
I wouldn't say so. No,
data optimized, newly trained data optimized version along the lines of Chinchilla?
If I had to guess, it's probably still a GPT-3 model size variable, because when you look at Chinchilla scaling laws, GPT-3, when it was published, it was severely undertrained.
Yeah.
Right? Like it was very far from fully optimized. And my guess would be that training another dense language model to a larger scale is a very, very hard thing to do, so to speak. So they probably optimize a lot of their existing large GPT-3 and like existing infrastructure to run all of that experiments and inference.
And we'll talk a lot more about language models at NeurIPS, but my feeling is also that the sort of whole chain of thought and intermediate results and prompt engineering, that they've kind of taken that to a whole other perfection level. That it's like the prompted output you get from ChatGPT is not just what you prompted and what the model produces, but there are some like intermediate steps that the model does with itself before producing the final answer.
Absolutely, yeah. I totally think that they're probably doing some of these kind of advanced prompting techniques. It's not just they feed your input to the model and then its output. There's probably a lot of kind of like pre-pended templates and post templates
about
what you're doing,
yeah.
including chains of thought and including a lot of these
since many of the papers on NeurIPS have been out for a while, maybe they have just fed all the papers in NeurIPS.
Could be that they augmented their training.
Let's dive into NeurIPS because it was really a spectacle. So 10,000 people here in person in New Orleans in these great halls. Maybe they're all playing with ChatGPT on their phone while this photo was taken.
Yeah. But I think that this photo captures very well. This is in a poster session, right? And there's like this massive venue where there were. How many posters were there at every session? Maybe like.
Well, I think there were eight poster sessions with about.
Six poster sessions.
Six poster sessions with a couple hundred posters per session.
Yeah.
So total almost 3,000 papers. Every paper was presented as a poster, so it was really fantastic. Mm-hmm. There were only the keynotes and the posters. There were no regular talks, and so that's about 500 posters per session. Yeah, and it was really hard to navigate. It was like a hard work, but you could talk to amazing people and really understand their work closely. Yeah. But it was very hard to navigate, especially since these signs were made by NeurIPS organization probably in 2010 or something like that. And they had these signs there, but they obviously didn't fit any of the categories of the posters. It was completely outdated. You can throw them in the trash. Yeah,
the topical organization was on the poster session was a bit kind of hit and miss. There was some. I feel like there was some vaguely kind of location-based topics, but it was not. You pretty much had to walk everywhere to see stuff because you'd miss a lot of stuff.
So that's not a great way to navigate the conference. So we made a better way actually with Zeta Alpha. On our website, zetaalpha.com, you can find this map of NeurIPS. So basically what we've done here is map out all the 2,900 conference papers and the 600 or so workshop papers into this semantic space based on neural embeddings, and then had actually some help with from OpenAI's GPT-3 to label the clusters. And these are some of the topics that we're going to talk about in the rest of this webinar.
Mm-hmm. Yeah, absolutely.
And this is we think a better way to navigate the papers, and it's also, Sergi, what you kind of used to write your guide, right?
Because exactly. Yeah. So as we did in previous years, I wrote this sort of blog post overview of the content of the conference, and I used a lot of these visualization tools to get a kind of bird's eye view of topics at the conference and sort of split this navigation into 10 key topical sections, and then some of the literature in each one of them. So for instance, we have large language models and prompting. We have diffusion models for a lot of computer vision, but not only that, also a bit of text and other
diffusion models were really kind of the rising star, right?
Yeah,
like last year it was very
small
topic.
This
year
very much mainstream. Mainstream. Then we have a lot of stuff on self-supervised learning, graph neural networks, neuroscience related research, data sets and benchmarks, robustness, federated learning, adversarial attacks. So all of these.
So we can discuss all 50 papers here. So if you and a lot of them are quite like the blockbusters. So if you want to get a quick overview of what was the main sort of innovations, what were the main innovations in the conference, read Sergi's blog. So here's a little bit of a visual impression of the conference. So it's in the New Orleans Convention Center. people running around long hallways. The convention center is so big.
Yeah,
NeurIPS is like a very small part of it.
Yeah. There was this workboat conference also going on.
Everybody, there's a big meme track on Twitter about workboats, which is much bigger. But if you came to the entrance of the convention center, it was still a 15-minute walk to get to the actual conference.
Exactly. Yeah, you really had to account for that. A bit late the first day,
And so there's an expo. Here you see the TikTok booth. I made a little picture for my daughters, and there were booths from all the major tech companies: DeepMind, Google, Microsoft, Meta, Sony. Who else was there?
From the big, Apple, I don't know if you mentioned them.
A lot of hedge funds also, right?
Yeah. Hedge funds, Spotify, Cohere, some of these more.
Yeah, and a lot of smaller booths. So that was fun. And
AstraZeneca was also there.
Yeah. And so here you see some numbers of the conference. I think 10,000 people in person. Next week is going to be the virtual version. It's much smaller. It's only 3,000 people. I don't know. But really, the posters live, that works very well. You get to talk to people. It's really different.
Yeah, I feel like that's one of my main highlights, right? Just like
I did not love Gather Town last year.
No, I think that's pretty unanimous. I mean, there's a certain bias to the people who attended in person this year, but I feel like that was one of my highlights. Like you just get such a different interaction, right? When you're like face to face with the authors of the work.
It's back to the old days.
Yeah, exactly.
It was like that,
and it's just so much more efficient too, because like to get to kind of like to a point where when you learn so much more about what's behind the paper, and people are like authors are gonna tell you so many different things, but in the setting of just talking one-to-one versus in a kind of more kind of formalized virtual setting, right? And it's gonna be way more informal. It's gonna be way more about like where things work and really like all of the things that didn't make into the paper. You kind of like get a sense for that, which is
absolutely So we did a very quick analysis of the affiliations of the authors at the conference. This is just a quick snapshot. We're gonna publish a little bit more about that, like which companies are publishing at NeurIPS, how's kind of the geopolitical. But we can say that the growth of China from last year is again about double the percentage growth of the average. So China definitely making big advances in AI.
And certainly United States and China are still pretty much the two big production centers of AI research, right?
Yeah.
Europe is very much.
Well, if you add everything up for Europe, I think actually the growth percentage of the Netherlands was larger than that of China. So.
Oh wow! Okay, maybe there's. I mean, there's a lot of stuff moving in the Netherlands, right? So. Hopefully,
and notable also Australia. There were a lot of papers from Australia, over double the amount of last year. So we'll be publishing a little bit more on these numbers and drill down deeper. So 10,000 people. That's like a hive mind of deep learning elite. This is here you see in this video the size of the thing. So. This is the main keynote.
Yeah, the main keynote, like space where the big keynotes were presented, which had a massive capacity and had a bunch of like massive screens for everyone to see.
So it could actually easily fit 10,000 people.
Yeah, exactly, like probably, yeah.
So what was going on there?
The first keynote, I was interested. I found it kind of interesting that they chose such a controversial or such a kind of topic about consciousness. What did you think?
So the opening keynote was by the philosopher Dave Chalmers, well known for his concept of the the hard problem of consciousness, and his song "The Zombie Blues," not to forget, which he did recite at the end of the keynote. And he chose this controversial topic: are large language models sentient? Kind of mirroring or echoing some of the controversy that was around the Google engineer who thought that Google's Lambda model was sentient.
Yeah, and also Ilya Sutskever tweet that started a bit of a kind of...
Which was probably about ChatGPT, which he was building at the time. But Dave Chalmers toned it down a little bit, so he changed the title. The actual title of the keynote was not "Are large language models sentient?" but "Could large language models have consciousness?"
Yeah, which is actually more lowering the bar of
a little bit. Yeah, so like in the future. Or something.
Exactly.
And consciousness is obviously for Dave Chalmers himself a little bit of a technical term, which has a little bit better sort of operational definition than sentience, which is kind of a spiritual concept, right? What was his conclusion? Well, the conclusion was yes.
I mean, the conclusion was for him yes, although he gave always. So he basically gave like a bit of an overview of the current state of the art and some sketches of what could be a little bit closer to empirical study of what with consciousness.
Basically, it's like a checklist of
a bit of a checklist of what could kind of indicate this, but still a lot of the talk was about probabilities, not about any kind of definite.
And he did kind of reveal himself in two important ways. One, as a kind of machine learning fanboy. Right?
Yeah, true.
He confessed to being somewhat of an amateur machine learning enthusiast.
Yeah, exactly.
And second, his bar for consciousness is not that high. So he stated basically that we will probably reach a level of consciousness that other animals, like fish, for example, have in the next few years.
Yeah.
Right?
And if we have to pin it down to a number, I think he said current language models plausibility of consciousness was 10% or something like that.
Yeah.
And he said could have I think that his prediction for the next decade was in the ballpark of 50%. So.
Yeah. Well,
that's his take.
He's an expert.
Yeah.
A philosopher.
Yeah.
All right, that was pretty cool. The other very highly anticipated keynote was by Geoff Hinton, of course, one of the founding fathers of the whole deep learning field. He actually got the keynote. But also
test of time
award for the AlexNet paper with Alex Krzyzewski that kind of launched the deep learning revolution 10 years ago. It's not more than 10 years ago.
No, it's really nice.
At NeurIPS.
What do you take from that keynote?
First of all, everybody was sitting there in their big hallway. And,
expecting.
Cho did the introduction, and everybody was expecting here comes Geoff Hinton and climbs up the stage. But unfortunately,
he appeared on the screen.
He appeared on the screen from his home in Toronto, I guess.
I guess Toronto. Yeah. So that was a bit of a downer. Yeah.
That was a bit of a downer, but the lecture was well worth it. And basically the guy who got us hooked on backpropagation, one of the co-authors on the backpropagation paper in 1986, he is trying to get us cold turkey. No, there's nothing wrong with backpropagation, right?
No, but he's now very concerned in these alternative algorithms that are more plausible,
biologically plausible.
Yeah, more biologically
brain
plausible.
inspired.
Yeah, exactly.
So the argument is that obviously in the brain you do not have backpropagation of gradients. Those connections that could potentially backpropagate those gradients are not there. but you do have a lot of recurrent connections.
Yeah, so he basically outlined some type of algorithm which only performs local updates and some type of contrastive type learning, which seems to
self-supervised learning. Right?
Yeah, exactly, and that seems to work quite reasonably well in toy examples. And he has a bit of intuitions and little theories about how this could potentially correlate with phenomena in human brains such as sleep, and it was an interesting kind of like overall thing, but it's still far from kind of a state like a maturity of an algorithm where it might like really revolutionize something. So
I don't know. He's launched a couple of these wild ideas.
Yeah,
usually they're pretty good. And if you want to read more about it, there's a paper from yesterday on Geoff Hinton's website, the forward algorithm, some preliminary investigations. And the first question is, what's wrong with backpropagation? So
and I guess if we can end with one funny note on this. Geoff Hinton said that he was doing and encoding these toy experiments himself.
It's important to do the coding yourself so that you understand all the details.
But when asked about what frameworks he was using MATLAB, which made the crowd kind of laugh and applaud, and it was a very
he outed himself as a MATLAB user, and he refused to open source his code because it was very sloppy and badly coded. So. That was funny. All right, so back to the poster sessions. There were a couple other keynotes, of course. The videos are on the NeurIPS site. But the main meat of the conference was in the poster sessions. Right?
Absolutely, yeah. So like we've said, there were a bunch of papers that were already quite known, and
famous.
Famous, and we have a selection here. We have like the Chinchilla about the scaling laws of optimal scaling of model parameters and number of training tokens.
Yeah, which basically earlier this year completely redefined this discussion about the scaling laws, right?
Yeah, exactly, and they basically trained a 7 billion parameter model that for longer and showed that it outperformed larger models, which is having a large influence in like all of the subsequent language models. We have the chain of thought paper about how much better reasoning you can get out of these language models just by making them output their kind of step-by-step reasoning.
Yeah, it was a very influential paper. It basically sort of turbocharged this whole prompt engineering, and we'll say a little bit more.
Yeah, exactly. We have Flamingo from DeepMind, also visual language foundation model, important Imagen, which is kind of like Google's version of DALL-E. You could say it was also very popular.
Diffusion model based. Image generation from text.
Exactly. And finally, this InstructGPT, which
is very old. It's from February.
It's
from OpenAI, right?
I mean, like the release. Funnily enough, the release that OpenAI made was very much implemented fine tuning using a lot of these techniques on their production models that you can use on their.
Well, I think already sort of the Da Vinci GPT models use a lot of the stuff in InstructGPT. Rumor has it it's not the exact version, but there are definitely a lot of instruction tuning in the existing GPT-3 models. And I think it's the major sort of difference between what OpenAI offers and what other language models offer.
It's definitely like the secret sauce of OpenAI being so successful and their models being so good is
reinforcement learning from human feedback.
Exactly, and that's what they do there. I'm pretty sure they didn't kind of introduce. They were not the first ones to introduce this concept of reinforcement learning from human feedback, but they use this to improve the quality of align the generation of the language model much better with what humans want when they do prompting.
So it's very cool that you can see these people in person and talk to them. And one little detail that we want to point attention to is the T-shirt of the guy from OpenAI on InstructGPT.
That certainly raised a lot of eyebrows. He has an FTX T-shirt.
FTX T-shirt. I don't think OpenAI was funded by FTX, but Anthropic is, which is the company of the people who ran away from OpenAI to be more aligned with human, build more aligned AI.
Yeah, it's certainly going to be interesting.
So I think there was a little bit of a how do you say that? Like a jab at the Anthropic people that he wore the T-shirt.
It could very well be, yeah.
All right. So more about language models.
More about language models, like we said, a chain of thought. Another one that was very interesting and it was already a bit well known was the STAR paper, the self-taught reasoning paper, which
what
was...
does that do?
Sorry?
Can you explain a little bit what it does?
Yeah, absolutely. So they basically have this reinforcement learning type of setup where a language model will output chains of reasoning and an answer. Like given a question, will output a chain of reasoning and an answer. And then they will use an existing data set to sort of have a reward function that says, okay, if the answer is correct, we're going to accept that this chain of reasoning and answer is kind of a good chain of reasoning, and then we're going to fine-tune the model on that data. So that you're going to have this setup where you have a language model augmenting the data that is going to be itself trained on. So you have this model like generating potential synthetic training data, a method to know whether that data is good or not, and then kind of a virtuous cycle of retraining the model on that.
And it leads to pretty large improvements on benchmarks.
Exactly. And
like common sense reasoning benchmarks and things like that, right?
Exactly. I think in common sense reasoning tasks. But very interestingly, this is a setup that can be applied to a lot of other problems, right? Like is it in the next slide? I think the Minerva paper for reasoning in the math domain. So there were a lot of works here at NeurIPS that had this sort of combination of language models with some sort of reinforcement learning loop in which there's synthetic data, not synthetic, like data generated by the language model and some sort of reward function that allows the language model to kind of itself improve generation. And this seems to be a very powerful learning setup. That doesn't require...
And really the chain of thought paper is the one that started it, I think, right? Because it kind of broke away from the paradigm that it's just a language model, which is like probabilistically generating the next word. But if you prompt it to behave in a certain way, you kind of, by asking it to, what's the prompt again for chain of thought? Let's reason step by step.
Yeah, well, that one is the language models are zero-shot reasoners, which is like the version of chain of thought in the zero-shot setting, right? Where you don't add any chain of thought in the prompt, but in the chain of thought framework.
They do the prompting with the chain of thought examples.
Exactly, they basically have chain of thought examples, and then the model.
And I want to just point attention to this little graph in the lower left corner of the screen. Which kind of shows the scaling law effects, and then the purple graph is the regular sort of scaling law, and then the light pink version is sort of the turbo boost that's given by this chain of thought technique. So it really makes large language models capable of doing things that they're not normally capable of at a certain scale. And it just completely shifts the the direction of the progress on scale versus quality. So I thought it was a big deal, and I had a very nice discussion with Dale Schumanns, one of the authors of the paper. He explained what his intuitions were, why this was the case, and he said, well, basically transformer-based language models are a new type of computing engine. And you're really kind of making, with this chain of thought technique, you're making it possible for this type of computing engine to break down its reasoning steps into like a divide and conquer type of small steps, and therefore be capable of sort of universal computation.
I mean, it certainly, at least to me, it feels like this whole space of advanced prompting, we're just at the beginning of it, right? So we're going to see in the next year so many more setups that leverage all of these techniques and improve on them, because this is still pretty much first iteration.
It's just being discovered kind of this year.
So I think it has still a long way to improve, which is super exciting.
So one other applications, and also kind of witnessing that there's a lot of work at I think it was from DeepMind as well. So kind of doing other things with these large language models. So this was a paper which used them as kind of moral judgments. Basically, using this kind of chain of thought to elicit arguments for why something is bad or good for humanity or for the actors in the story, and then using multiple of these reasoning chains to then fundamentally end up with a decision of whether to do something or not to do something. So I thought it was pretty interesting application of that.
And there were also some language model line of work. I don't think we included any of those here, but work on the explainability of language models, right? On language models that also learn to explain their reasoning and their answers, and try to more accurately calibrate their answers, so they're more trustworthy in the sense that their answers correlate with the being factually correct, and all of.
Another application here is to use large language models to kind of find arguments for certain positions which are less controversial, to kind of counter the radicalization or polarization online, to find kind of bridges between opposing points of view. I thought that was also really interesting. And Minerva.
And finally, Minerva. We got to talk to interview one of the authors of this paper, which showed how with the right kind of data focused on math, language models can be better than. I think that the kind of like punchline was better than the average high schooler on math reasoning exams.
Yeah. And this was before ChatGPT, so I think high school exams are over because the general consensus is that with ChatGPT, any high school student can answer any sort of,
especially a lot of opinion articles or like essays. All of these things are very convincingly generated by ChatGPT, for instance. But going back to Minerva, I think that one of the most talking to the authors of this work was super interesting, and I feel like this is just a very small first step, and from the sense that I got from them, the next step that includes all of these bootstrapping reasoning techniques is going to be even more impressive. So I'm really looking forward to the kind of version 2 of these papers. And
one last thing about large language models, I'm really happy personally that the field has converged on this kind of this name, large language models, or LLMs, as a kind of unifying term rather than the somewhat grandiose foundational models.
On that, Stanford got quite a bit of backslash for that.
Absolutely. So, but it's not only large language models. There's obviously a huge amount of kind of more theoretical work around, machine learning theory and algorithm optimizations, and it's 3,000 papers. So,
and a lot of the out of the box neural networks people use in computer vision are definitely still complex. There's a lot of ResNet units in a lot of the computer vision papers that don't look at the architecture stuff so deeply, but care about other aspects of computer vision.
Yeah, so here just out of the multitude of things, just two kind of interesting things that I found. One was a paper from Schmidhuber's group in Switzerland that introduces kind of an LSTM element into the transformer architecture, reducing the complexity of the attention layer in a nice way, and then building a bridge between those two architectures. Had some pretty good results. And Matroshka, did you see that as well?
Yeah, I walked past it, but I didn't stop to talk to them.
So it's very interesting if you're using embeddings, like for sentences or documents or images. The Matroshka algorithm, Matroshka are these Russian dolls which are stacked into each other, allows you to create embeddings of which any prefix part will be kind of a good approximation of the rest.
Okay.
So basically you can take a bird embedding of 700 dimensions, but you can also take an embedding of half of that, or 1/4, or 1/8, or just a very small embedding of 10 dimensions.
Okay.
And it will work almost as well as the full thing.
I see. It's very interesting, yeah, for the whole aspect of efficiency, and which is also like had a lot of there were a lot of papers. There was this paper on training a neural network on 256 kilobytes of memory. Wow. I remember it had a lot of. I didn't get to talk to the authors, but it had a lot.
1 bit precision.
It had a big crowd around it.
And the other sort of blockbuster paper was LLM int 8.
Yeah, exactly. This optimization technique to run inference.
To do inference very quickly.
Yeah.
All right. The stars of the show, though, were, besides language models, were diffusion models.
Absolutely. Yeah, diffusion models on image generation, and not only that, but now we are seeing diffusion models applied to video generation, and there were a few...
Of long videos. Even in September, it was not... Nobody thought that long videos were within reach, but it's been done now. This poster also was kind of the star of the poster session with at least 8 iPads attached to it.
8 iPads are worth...
8 iPads is all you need. So.
It's... it was kind of like one of those things that everyone... It was the obvious next step, right? After everyone saw this text-to-image generation, everyone was wondering, how can
maybe it's good to explain very quickly what is a diffusion model and why is it like so much better?
So I feel like calling it a diffusion model might be confusing in a sense, because like diffusion is more of it's almost like a self-supervision technique. It's kind of a way of doing denoising autoencoders. Basically, you have some data, right, and you apply noise to it iteratively, and then this process is very easy to do because you just kind of add noise to write. You have an image, you have add noise, but then the cool thing is that you can now train a model to do this process in the opposite way, right? So it's this kind of like modeling technique where you have a progressively corrupted data, and you train to progressively uncorrupt data. So this works very well for continuous data like pixels. And then one of the really cool things is that this whole process can kind of very easily be conditioned to any arbitrary sort of information. So you can have this, for instance, text conditional image generation that works so well. Or you can do things that are not possible with autoregressive language models. For instance, they had this paper where they do text generation with diffusion models, and because this process is very much progressive thing on like building a sentence, you can condition it so that the sentence has a certain syntactic structure, for instance. So you can kind of have a setup where you have some sort of classifier that guides the diffusion process and kind of incentivizes it to converge into a sentence that has a specific syntactic structure, or can it pretty much any arbitrary kind of conditioning signal.
Or condition on text and like a little storyline, and then produce long videos like here. So, I don't know if this was actually text conditioned here. I think it was just...
I don't remember actually.
Image conditions. But,
just like continuing a video.
And a pretty nice sort of different directionality in diffusion models was in this poster. Semi-parametric image diffusion, which basically adds a retrieval augmentation step. So you can not only like a condition on text and then use the denoising process to generate an image, but you will actually first retrieve some images using a clip model, and that can kind of set the stage, and then you do diffusion from that.
Exactly.
Paper.
And you can traditionally all of the information of the corpus would be kind of like implicitly encoded in the model weights.
Yeah.
But in this way, you have an external memory, and the cool thing is also that you can swap this database
it's
of
more
images.
parameter efficient, but you can also swap the
Exactly.
database.
So you can have a lot of flexibility in this way. So that's super interesting. You can see
more on diffusion models. So on language.
Yeah.
So diffusion models were not. Were not so easily applicable on language data because of the categorical nature of language. But there was a really nice work, Diffusion LM from Stanford, on making this work for kind of syntactic trees.
Yeah, exactly. Except you can condition this diffusion process into like this. You can do a whole set of new things that you couldn't really do so well with autoregressive language modeling.
And then not a paper at NeurIPS, but one that dropped on arXiv during the NeurIPS by Sander Dieleman, who we got to interview at the conference from DeepMind. He further improved these language modeling techniques using diffusion models. It's a very nice paper that kind of rebuilds BERT basically, but then with diffusion models.
Yeah, exactly. And it seems like there's still an infancy stage, right? This diffusion language model is still not as good as the autoregressive, but they certainly have certain kind of orthogonal advantages. So we're certainly going to see more.
If you already look at the progress that has been made in images from the first diffusion models to what we're seeing now with Imagen and what's the other one? Party and all those.
And semi diffusion and
exactly. The quality increase has been amazing. So it's a very promising path for language models as well.
And the reinforcement learning is massive at NeurIPS.
It's about one third of the papers is on reinforcement.
It's almost its own conference, what we saw in NeurIPS was a lot of these kind of symbiosis between language models and reinforcement learning, like using language models as priors for reinforcement learning to kind of be more sample efficient. There's this MindDojo paper that won the one of the best paper awards
in the datasets and benchmarks track, right?
Exactly, datasets and benchmarks track. And we also got to chat to the authors. You can check that conversation on YouTube. And again, it's like one of these initiatives that leverages large-scale internet data to sort of train an agent in a reinforcement learning type of setup, and does really well on
in the world of Minecraft.
Exactly.
Right? So MindDojo is like a simulation environment for using reinforcement learning. Using pre-existing knowledge from the internet, from both text and video, about playing Minecraft, to teach an agent to play Minecraft really well in this simulation environment.
I was gonna say, besides that, there's a lot of work on the policy gradients side of reinforcement learning, and I would say that still like a lot of the kind of foundational struggles of reinforcement learning are still very much on the kind of top of everyone's minds.
Absolutely, it's not quite there yet, but there.
It's like this whole aspect of like sample efficiency problems with like the efficiency of exploration phases. All of these is still very much a lot of the problems on reproducibility, right? Are still very much on very much a live topic of discussion.
A brittle set of algorithms.
Exactly.
Which kind of also is a bridge to this paper. So these guys here, AlphaZero agents robust to adversarial perturbations, show that the AlphaZero deep reinforcement learning system, which beat the world champion a couple of years ago, can make completely stupid moves that no human player would ever make. and if you kind of can trick it into one of these corners of the space, it doesn't have good representations there, and it just like completely loses.
Yeah.
We still have some chance to
beat
the AGI.
Not for long, but yeah.
What else
and
about reinforcement learning?
Some applied to the neural radiance fields. We have this single life reinforcement learning, which is a kind of like a different paradigm for reinforcement learning, in which there's no episode resets, right? So like the objective is just to complete a task with very limited information, and not so much do it efficiently, but just kind of like get it done without dying in the process. And like we've said a little bit before, this whole language models and reinforcement learning, they use in this paper language models, instructions, and condition the policy learning algorithm to leverage the information on like the instructions of games, for instance, so that the learning process is much more efficient. So there's a lot of works that leverage is kind of like.
I mean, this direction makes complete sense, right? Like, no human figures out the entire sort of risk-reward structure of the world without some guidance from their peers in the form of language, right?
Exactly.
Instructions are just such a powerful way to get started.
Absolutely, and you know, there's so much untapped power in these large pre-trained language models, right? So much knowledge of the world is encoded in there. A lot of these works, like you can kind of conceptualize it as extracting, like leveraging that kind of dark matter of
you don't want to start by random exploration.
No, that's for sure. No.
All right, so
we're close to the hour. But I think we still have time to just...
The data sets and benchmark task track, that was really fabulous.
Everyone was super excited, right, about this data set and benchmark that. I feel like this whole data set...
The second year did they do that or something? It's fairly new track at NeurIPS.
Fairly new, but everyone is very excited that this kind of like data set and benchmark kind of got promoted to its own status and very much in the forefront.
And in a field where everything depends on data, like progress depends on being able to work on very large, high-quality data sets. One of the other keynotes from Isabelle Guillaume was also like, the amount of data and the quality of data is what moves us forward, not so much the algorithms, right? So
absolutely. So these papers have, I would guess, on the average, a much higher impact than a lot of the other papers that have focus on modeling, right?
Yeah.
On the
and for example, all of this work in sort of image generation and diffusion models, a lot of it has been based on this Lion data set.
Absolutely, the new stable diffusion model
is trained on it.
And I'm pretty sure that the stable diffusion paper you just mentioned before on retrieval augmented image generation also uses this Lion 5 billion data set.
They also won the Outstanding Paper Award, I think, right?
Exactly, yeah.
In this category. One benchmark that I found really interesting is the forecasting benchmark, where you're really trying to pick the winner in the soccer world championship based on reading everything about the teams that has been published in the last year.
Yeah,
I thought it was a pretty interesting data set.
Yeah,
and they have about 4,000 prediction questions like that, and a leaderboard, and you can really compete for this. All right, so
just very quickly, GNNs were also like a massive topic. We just have like two very small sample papers here. One on the 3D drug design sphere of applications, and the other one using GNNs to make exploration more efficient in a reinforcement learning setting.
I mean, this drug design obviously is a very hot field of applications. There were a lot of pharma companies at NeurIPS, and
absolutely.
There was a special competition, I think.
And another area of applications that I didn't get to include here is like GNNs applied to partial differential equations. There were quite a bit of work on that front, which still feels like infancy, but it's definitely like a lot of people excited about that.
for like modeling scientific systems.
Scientific modeling, simulation, physics simulation, making them more efficient.
All right, so this is the last one that we want to highlight. If you think that everything is deep learning now, there's still one small
corner of the
village that resists the Roman Empire. Not surprisingly, it comes from France, from the Gallic region, and there was this really nice poster. Why do tree-based models still outperform deep learning on typical tabular data? From team at Indria, and we have an interview on our YouTube channel also with Gal Verrico, one of the co-authors of this very nice paper. And basically the conclusion is XGBoost is still the best algorithm for tabular data.
Yeah.
So, but there was kind of optimism. They didn't feel that it would last for very long, right?
Yeah.
Like that, we have a bet that next year is gonna be deep learning for tabular data as well. There is a workshop actually today,
about
specifically on this topic.
But we wanted to just quickly shout out. You can go to our YouTube channel to watch all of these chats that we have been having with researchers, people at
a bunch of authors at the
NeurIPS.
conference.
So far we have 4, but probably by the time you watch these on YouTube, it might we will have uploaded even more. So I think it's a really good way to get a sense of like what the vibe.
Informal chats with authors of papers and interesting influencers. This Carper AI is interesting because they want to build an open source
InstructGPT. Exactly.
And they're affiliated with the Eleuther collective, bunch of smart grad students. So that brings us to a close. I just wanted to show you a picture of the job board at NeurIPS. So while deep learning researchers are kind of completely pushing the boundaries of what's possible with technology, the job board is not very high tech. It's the same thing. Look, probably 1990 with just scraps of paper on a board. There were a lot of companies recruiting at NeurIPS. What was your feel of the sort of the job market?
It's hard to say, honestly. I feel like it has to be relatively hot because all of the big companies at their booths seem to be interested in getting the context of their last year PhDs to hire them, and it's a big investment for them to come here. So it must pay off in some.
My feeling, it was a bit pro forma. I mean, these booths are booked long in advance. And there has really been a hiring slowdown at big tech, right? You see that at both Meta, Google, and Amazon. They all
either stopped
fired a large part of their significant amounts of people, and they have a frozen hiring. So I think they also kind of don't want to look like they're stopping hiring, but in fact there will not be a lot of recruitment this year. But of course it's important to stay in touch with talent. I talked to some of the hedge funds that were there. They're like, we're getting a lot better quality candidates now.
Oh wow!
because
that's so interesting.
Because companies have stopped hiring. And this other picture is from the Chinchilla poster, and an in-person conference is a great way to get sort of the latest gossip. You even in the name tags, you find some interesting discoveries. So the main author of the Chinchilla paper, for example, is no longer with DeepMind, but with Inflection AI. I saw Karen Simeon, who's their sort of chief scientist, walking around. And I think he was recruiting a lot.
Nice.
All right, so let's wrap it up. Kind of summarizing both the job market and the academic perspective on the conference. I think this was a really nice picture. Artificial general intelligence by the end of your PhD. Changed my mind. What's your perspective, Sergi?
I think it's a bit of a an edgy, provocative type of exercise. But I mean, we were talking about this yesterday. I feel like there's certainly a very large crowd of people at NeurIPS and at DeepMind and at OpenAI that properly believe in this vision of like AGI is certainly achievable within
and we're working on it.
Within a reasonable time frame, and
it does feel like things are going so fast that like when you're doing a PhD, you really have no idea whether your current ideas are going to be relevant at the end of your PhD. So I think it's still always hype is a little bit bigger than reality. But
I mean,
so the other side of things is these were one of the most popular T-shirts given out at NeurIPS. So just don't do it.
Certainly a variety of opinions, right? And I mean, there's a lot of diverse crowd at NeurIPS. You have like a lot of kind of more academically oriented and a lot of.
Well, if 10,000 very smart people are stampeding in a certain direction, it's very hard to change their course. But regardless of which side you take on the AGI discussion, we all are passionate about the technology in AI and deep learning, and if you want to find better tools to keep you informed, of course, keep tuned in to our Trends in AI webinars, read our blogs, and sign up to use the Zeta Alpha AI Research Assistant, which will help you to discover interesting things. Thanks for tuning in, and if you at your NeurIPS or hearing this webinar, you can use the NeurIPS 2022 promo codes to sign up. Thanks for tuning in.